Welcome back, aviators. Today we're talking about RVSM, or Reduced Vertical Separation Minimum. RVSM is a specialized airspace concept designed to increase airspace capacity and optimize flight efficiency. By reducing the vertical separation between aircraft from 2,000 feet to just 1,000 feet between flight level 290 and flight level 410, we can safely accommodate more traffic and reduce fuel consumption. So, where did RVSM come from? RVSM was introduced by the International Civil Aviation Organization to address the increasing demand for air traffic capacity. Before RVSM, aircraft above flight level 290 had to maintain a vertical separation of 2,000 feet. However, studies showed that modern aircraft systems, particularly altimeters and autopilots, were precise enough to safely reduce this gap. RVSM was implemented in the North Atlantic in the 1990s and has since expanded globally, with almost all major airspaces adopting it by the early 2000s. The result? More efficient airspace usage, reduced delays, and significant fuel savings for operators. Now, how do operators gain approval to fly an RVSM airspace? First, the aircraft must meet strict technical and maintenance standards. These include having dual independent altimeter systems, an altitude alerting system, an autopilot capable of maintaining altitude within tight tolerances, and a secondary surveillance radar transponder with altitude reporting system that can be connected to the altitude measurement system in use for altitude keeping. Additionally, operators must demonstrate compliance with ICAO's performance requirements through detailed documentation and periodic monitoring. Once approved, a certificate or operational specification is issued, allowing the aircraft and crew to operate in RVSM airspace. Operating in RVSM airspace isn't just about the equipment. Pilots and operators must adhere to strict regulatory requirements. For instance, altitude keeping systems must undergo periodic checks to ensure accuracy. Flight crews need to be trained on RVSM procedures, including pre-flight checks, in-flight monitoring, and contingency actions. These requirements help ensure safety and standardization across all RVSM airspace globally. Captain?
Hi. Let's see what the A320 FCOM says about RVSM and those altimeters check you just mentioned. First, let's check the required equipment and functions for RVSM. We need 2 ADRs plus 2 DMCs. We need 1 transponder, 1 autopilot function, 1 FCU channel, 2 PFDs functions, and 1 flight warning computer. Okay, once we have all of those, what shall we check on the ground before commencing our flight if we know that we need to enter RVSM airspace? First, check that the aircraft is approved for RVSM operations. Check the weather forecast for the intended flight route. And now, check your altimeters. Check that the difference between each altitude indication displayed on the PFDs and the airport elevation is less than 75 feet. Then check that the maximum difference between those PFDs is less than 20 feet. And last, check your standby altimeter. If your aircraft is equipped with ISIS, then the maximum difference between standby and primary altimeters should not exceed 100 feet. In case of having a mechanical standby altimeter, the difference cannot exceed 300 feet. Okay, so we have checked, and we comply with all the requirements. And we are on our way. Our job is not done. We must check the altimeters prior to enter RVSM, before passing flight level 290 and also every hour within the RVSM airspace. But check with your operator for specifics. We don't need to memorize the maximum tolerance in flight. But if we suspect we may be out of limits, we can check the following table in the FCOM.
Thanks, Captain, for all that information. See you later, and try not to eat all the crew meals. So, what happens if in the middle of your flight, at flight level 360, for example, you can't comply with RVSM requirements? This might occur due to equipment failure, such as a malfunctioning altimeter or autopilot. In such cases, inform ATC immediately in the following cases: failure of both autopilots, loss of altimeter redundancy, excessive altitude discrepancy, even severe turbulence. This is because it may be impossible to maintain our maximum altitude deviation of 300 feet for our assigned level. Contingency procedures are designed to handle situations where maintaining RVSM is impossible. According to the International Civil Aviation Organization guidelines, other than informing ATC, if unable to maintain altitude, establish lateral separation by turning at least 45 degrees from the original track. Descend below flight level 290 or climb above flight level 410 to exit RVSM airspace. These procedures prioritize safety while minimizing disruption to other traffic. And remember that operators of RVSM-approved aircraft must list a W in Item 10 of the ICAO flight plan, irrespective of the requested flight plan. Operators of non-RVSM-approved aircraft wishing to operate in RVSM airspace must submit an M in Item 8 of the ICAO flight plan, and in addition, STS/non-RVSM in Item 18. Finally, let's go over some RVSM-related phraseology.
Okay, so, for example, to report RVSM approval status, it would be affirm RVSM or negative RVSM. If we cannot remain within tolerance, we can use unable RVSM due turbulence or unable RVSM due equipment. If we can fix our problem, then ready to resume RVSM. You get the gist.
Thanks, Captain. Remember, clear, standardized communication ensures ATC and other aircraft understand your intentions, maintaining safety in this critical airspace. And that wraps up our comprehensive look at RVSM airspace. We covered its origins, approval processes, operational requirements, and much more. Whether you're studying for your ATPL or just refreshing your knowledge, understanding RVSM is essential for modern pilots. If you found this video helpful, don't forget to like, subscribe, and share it with your fellow aviators. Fly safe, and see you in the next video.